Assalamualaikum warahmatullahi wabarakatuh, and good morning to all my students. And we meet again. Okay, so today I'd like to explain to all of you another part of what we call Chapter 3 Numerical Method in our syllabus, which, as you see on the screen here now, 3.3 Trapezoidal Rule. Okay. So now the objective here is we are going to use the trapezoidal rule to approximate definite integrals. Okay, so why do we need this? Okay, first of all, there are some cases or some questions that we cannot simply integrate using the method that we have learned before in Chapter 1, Integration. Last time we integrate a function using simple integration method. We used the substitution method, integration by part, partial fraction. Okay, so now there are some cases, there are some situations that integral of the function of fx respect to the x, we cannot simply get the answers as you recall using the method that I mentioned just now. So in this case, we use the trapezoidal rule, okay, to approximate. Okay, to approximate means that it's not an accurate value of definite integral, but it's approximate. Okay, very close to the exact value. Okay, so the trapezoidal rule, if we integrate a function of fx dx from x equal to a until x equal to b, then the area between the curve of y equal to fx, the line of x equal to a until x equal to b, as you see here now, okay, this is a graph that we have seen before in chapter of integration, especially to find the area between the curve x-axis and also line of x equal to a until x equal to b. So then the trapezoidal rule, this method divides the area under the curve y equal to fx into n subintervals or n vertical strips, and the width of each strip is h. Okay, so from the previous graph, then we divide it into a few strips. Strips means that one here, okay, the first strips, the second strip, okay, and the third one, fourth, fifth, seventh, until might be y, the strip of y, n minus 2, n minus 1, and here. Okay, every strip has its, we call the border. First, 1, 2, 3, 4. Okay. Then 5 ordinates. 5 ordinates represent x0 until x4. So then we have 4 subintervals or 4 strips. Okay. To explain this, let's say, okay, so this is the graph of y equal to fx. We get subordinates of, let's say, from here, which is x0, x1, x2, and x3 until x4. 1, 2, 3, 4, 5. x0 until x4. Thus, the n, or the, we call the subintervals or the strips, are 4 of them. 1, 2, 3, 4. 1, 2, 3, 4. 5 ordinates from x0 until x4 and 4 strips. 1, 2, 3, 4. Okay, area of trapezium. So this is the, we call the side of A and B of and H here. So half here multiplied with sum of parallel sides, which is A and B, multiplied with the width, which is H. Okay, width of this H here. And then, so we got y0, y1, y2, y3, yn minus 1. Okay, this is for yn minus 1, and last final here, which is yn. Okay. The total of area of n strips is the sum of all trapezium area, the sum of all the area 1, area 2, area 3, until the last area here, final area here strips. Okay, so then we simplified all this. Therefore, the trapezium rule here is, okay, which is n less than or equal to 4. Okay. So, without wasting so much time, use the trapezoidal rule with 4 strips. 4 strips. So, if I recall, imagine something like this one here now. This is the graph of y equal to fx. So this is the first one. This is the first one. 4 strips. So consider as one strip, which is one ordinate and another one ordinate, y0 and y1. And then 2 strips means that there are 3 ordinates, 1, 2, 3, and then another one and another 1. Okay, okay. This graph fx is not represent this one here, just to show you that the strips, or when we have given here 4 strips, so we got 1, 2, 3, 4. Okay, so give your answers correct to 4 decimal places. Okay, so then the first one here now. Okay, the solution with 4 strips means that where n equal to 4. And then the h equal to, b minus a divided by n, according to the integral of the function just now, from 1 until 4, 1 over 1 plus x squared dx. Okay, so this is the b, 4 minus a, which is equal to 1, divided by n, equal to 4. This is our b, and this is a. Okay, so 4 minus 1 divided by 4 equal to 3 over 4, which is 0.75. Okay, and now, let's say if I give them into this box here, where this is the coordinate of 1, and here is 4. So the strip is 4. 1, 2, 3. 1, 2, 3, 4. 4 strips, 4n. Okay, and the distance between here until here, which is 1 plus 0.75 equal to 1.75. Okay, and then 1.75 plus 0.75. What about this? 1.75 plus 0.75, 5 over 2, or 1.75 plus another of 0.75, and this gives you 2.5. From 2.5 plus with another of 0.75 plus 0.75 equal to, here, 3.25, and 3.25 plus 0.75 equal to 4. Okay, so this tells us that the distance from one point to another point are all equal with 0.75. So from 1 x equal to a until x equal to b. So there are 4 strips, 1, 2, 3, and 4. Okay, so now if I sketch the table, write on the draw a table of this. Okay. Okay, so this is one of the example or model of the table. Okay, so then this is y equal to, this is our y. 1 plus 1 plus x squared. Okay, and 1, 2, 3, 4, 5. This is for x naught, x1, x2, x3, and x4. Okay, so it means that I need to add another column here. Okay, so now substitute x naught into substitute x naught with first one here, x equal to 1, and this is 1.75, 2.5, 3.25, and 4. Okay, substitute x naught, which is 1, into the equation. 1 over 1 plus 1 square. 1 square is 1, 1 plus 1 equal to 2, 1 over 2 equal to y naught equal to 0.5. Again, x naught equal to 1. Substitute here. 1 square is 1. 1 plus 1 equal to 2. So 1 over 2 equal to y naught, x naught, and y naught equal to 0.5. And then we put that y1 here, y2 here, y3 here, and the last final x end up here with 4, then y4, we put it here. Okay, x equal to 1.75, substitute here 1.75 squared, so then plus 1 and 1 over everything here. You may use your calculator, and this will give you 0.24614. Okay, 2.5, substitute here, 2.5 squared plus 1 and 1 over everything here, so then give you y2, which is 0.137931. And then also here 3.25, substitute here 3.25 squared plus 1, then 1 over everything here equal to 0.086486. And when y equal to 4, 4 squared equal to 16, plus 1 is 17. 1 over 17 equal to 0.0586, 0.0588, then 2, 4. Okay, so class, why did I separate between y0 and yn or y4 here on one side and the rest on the other side? There is a reason for this, okay? But before that, let's find out y0 plus y4. Then it is equal to 0.558824. Okay. And then y1 plus y2 plus y3, y1 plus y2 plus y3 equal to 0.470571. Okay, I'm sorry for this kind of, might be not proper with this way. Make some adjustment here. Example call correction, sorry. How can I say this? Okay. So this is for the summation of y0 plus yn, and this is summation of y1 plus y2 plus y3. Okay, I never mind. I add up another column here, and summation of y0 plus yn equal to 0.558824, 0.470571. Okay, next after this, integral of 1 until 4 function of 1 over 1 plus x squared dx equal to, now it's time for us to use the formula of h over 2, okay, y0 plus yn, and which is 4, plus 2y1 plus y2 plus until yn minus 1, and n here is 4, so n minus 1, which is y3. Okay, so now h, what's the value of h just now? It is 0.75 divided by 2. Okay, y4 plus yn, 0.558824, plus with 2 multiplied with the summation of all this just now, which is 0.470571. Okay, so then it is approximate to 0.5625. Okay, let's say this answer end up with 4 decimal places. Okay, that's it. Now, okay class, this is one of the method. If suddenly we met with a function that we cannot simply integrate, but doesn't mean that we cannot use to any other function that we can integrate, as we call learn it in chapter 1 of integration. Okay, integral of ln x dx, you may use the integration by part, yes, but doesn't mean that integral of ln x dx cannot be used in trapezoidal rule. But the main thing is, trapezoidal rule is a method for you to solve a function, integral of a function that cannot be used with other method easily. Okay, okay, now, so integral of integral of 1 until 8 natural log of x dx. Okay, so now from here where h equal to b minus a divided by n, where b equal to 8 minus a equal to 1 and divided by, according to the question, trapezoidal rule with 4 ordinates. With 4 ordinates, okay, let's say this is a box. So ordinate 1, 2, oh no, sorry. Okay, ordinates 1, okay, 2, 3, 4. Okay, so these are the ordinates, and from these 4 ordinates form 3 strips. 1, 2, 3. So with 4 ordinates means that the strips is 3 here. Okay, the strip is 3. So 8 minus 1 equal to 7 divided by 3. Okay. If I change this 7 divided by 3 in decimal, which is 2.33. Okay, never mind. We can use this actually. Okay, so now, let's say this is x equal to 1. What about this here? x2 equal to x, okay, x naught equal to 1, x1 equal to 1 plus 7 over 3 equal to 10 over 3. Okay. And then plus with another of 7. Okay. No. 10 divided by 3 plus with another of 7 over 3. 17 over 3 here, 17 over 3, and then plus with another of 7 over 3, then this one equal to an 8. Okay, so now, okay, then let's draw the table again. And another one here. Okay, so now y equal to natural log of x, and because we got 4 ordinates 1, 2, 3, 4, so there are 4 values of x. Okay. So now x naught, x1, x2, x3. Okay, x naught until x3. But how many values of x are there? 1, 2, 3, 4. X naught means that the beginning of the we call the value of x from 1 until 8 here. Okay, so now here is 1. This is 10 over 3, and this is 17 over 3, and here is an 8. So x naught at the end of here, x here, y naught until y3. Okay, so y equal to natural log of x. So when x equal to 1, natural log of 1 equal to 0. And when x equal to 8, here natural log of 8 equal to 2.075. 0, 7, 9, 4, and 4. So then we got y1 here and y2 here. Substitute 10 over 3 into the function ln of 10 over 3. Use a calculator. Okay, natural log of 10 divided by 3. Okay. If you can see it on my screen here, I will cause your calculator here now. Then it gives you, okay, so it is 1.203, 1.20397, and you may test also here 17 over 3, put it here now, it gives you 1.73460. Okay, now it's time for us to substitute all the, okay, before that, the summation of these two values of y0 until y3 here, which is 2.07944, and the summation of this value on the other side of this value here is 2.93857. Okay, so then next, integral from 1 until 8 natural function of ln x dx, okay, approximate to h over 2, which h equal to 7 over 6 is actually that. Okay, h is 7 over 3, which h over 2, 7 over 3, and then y0 plus yn plus 2, which is now y1 plus y2. So let's simplify this. Bring this above here, then 7 3 multiplied with 1 over 2. So it becomes 7 over 6. Okay, y0 plus yn equal to 2.07944. That. And plus with 2, please refer to the previous table. Okay, and this one is 2.93857. Okay, class. So from here, you may just straightly substitute into your, record the value into your calculator, and you will get here, which is 9.2827. Let's put this in 4 decimal places. Okay, what about this one here now? Okay, it mentioned here, this is the function, trapezoidal rule with 5 ordinates. So that 5 ordinates, x0, x1, x2, x3, x4, 1, 2, 3, 4, 5. Okay, so x0 substitute into y, it gives you value of y here, ordinates of y, 2, 3, 4, 5. So then how many strips do we have? 1, 2, 3, 4. Meaning n equal to 4, a equal to 0 here, and b equal to pi. Okay, so then the solution for this one, where h equal to b minus a divided by n. Okay, we rewrite the function here, integral of square root of sine x dx from 0 until pi. Okay, so now b, which is pi minus a, 0 divided by n. How many strips do we have just now? Yes, 4, equal to pi over 4. So means that here from 0 until 4, 1, 2, 3. Okay, from here, which is pi over 4. Pi over 4 plus pi over 4. Okay, make a mistake here. It is not 4 here. 0 until pi. So, okay, until pi. So then from pi over 4 plus with another of pi over 4 to pi over 4 or pi over 2. Add up with another of pi over 4. It gives you 3 pi over 4 and plus with another of pi over 4 equal to 2 pi over 8 pi over equal 1 over 4, 2 over 4, 3 over 4, and 4 over 4 or 1 pi. Okay, sorry. Okay, now from here again, okay, now so x naught equal to 0, x1 equal to pi over 4, x2 equal to pi over 2, x3 3 pi over 4, and then x4 equal to pi. Okay, so add up with another column here. Okay, now for y naught until y4. This is y1, y2, y3. So I'm not going to find the solution of this one by one. Okay, because for this one here, y equal to square root of sine x. Wait a minute. It should supposedly y equal to natural log of x, because this for both of this side and on the other side. I'm sorry. Okay, and supposedly write down here y equal to 1 over 1 plus x squared. Okay, I'll make a correction there. Okay, now for y naught, x equal to 0, sine of 0 equal to 1, square of 0 equal to sine of 0 equal to 0, and square of 0 equal to 0. And this one here, you may use your calculator. It is 2.89648, and this one here 1.040811, 1.173511, and this one here 1.43329, and this one 0 plus with this summation equal to 2.89648, and the summation on this side here is 3.647651. Okay, so now the integral of square root of sine x dx from 0 until pi equal to, okay, it is now pi over 2, h is pi over 4, divided by 2, then 0. Okay, class, I'm referring to the, we call this example solution is all correct until everything here in this table, which is different. Actually, that this value is for the other, we call the value of example after this. So I make a mistake here, sorry. Okay, make a correction here. I'm sorry. Okay. Okay, so x equal to 0, sine 0 equal to 0, square of 0 equal to 0, x equal for pi. You still remember this, the graph of sine x? Which is pi over 2 until pi equal to 0. So sine pi equal to 0, square of 0 equal to 0 here. And the rest of this is 0.84089. Again, I'm sorry for this careless mistake. Okay, it is 1.000, 0.84089. Okay, so the total here 0 plus 0, 0, and the total in this side here 2.68179. So this one here now, this part here, 0 plus 2 multiplied with the value of this 2.68179, and we call the solution of this approximate to 2.62106. Okay. Okay. I think that is the last final example here for this lecture. So now, integral of e to the power of x squared dx. Okay, this is one of the example that function that cannot be easily be integrate using the other simple method. Okay, so here now from 0 until 0.8. Okay, and then given that with 5 ordinates means that 5 ordinates. So then n, the number of strips is n equal to 4. So then h equal to b minus a divided by n, where b equal to 0.8 minus a 0 divided by 4, which is 0.2. And then, as usual, okay, 5 ordinates 1, 2, 3, 4, and 5. So x not equal to 0, x1 equal to 0.2, x2 equal to 0.4, x3 equal to 0.6, and x5 equal to 0.8. So then y naught until y5, and here is y1, y2, y3. So substitute 0 into the y equal to e to the power of x squared. So when x equal to 0, 0 square is 0, e power of 0 equal to 1. And here is 2.89648. So substitute 0.2 here. So then 0.2 square is 0.04. E power of 0.04 here, it is 1.040811. Here 1.173511, and this one here 1.433329. So the summation of this y0 until y5 equal to 3.89648, and the summation on this part here now is 3.64765. Okay, the next integral from 0 until 0.8 of e to the power of x squared dx equal to h, which is 0.2 divided by 2, a plus y0 plus y5, which is 2.89648 plus with 2 multiplied with 3.64765. Okay, press the calculator and it gives you approximate to 1.0192 up to 4 decimal places. Okay, for this topic, for this part of the trapezoidal rule, I do classify this as a easy topic. Okay, easy topic. Hopefully that you can understood the explanation, the content, and you may solve any question that been given in this record subtopic here. Hopefully that it helps you and you may focus on the other topics that might be difficult. Okay, so that's all for today. Till we meet again, and don't forget to continue your tutorial and your PSPM exercise. That's all. Assalamualaikum warahmatullahi wabarakatuh. Have a nice day.